Okay, so let's start. See, today we're going to discuss about OSI model, which is considered to be one of the very important and a foundation topic in networking. See, OSI model is something that you'll be referring throughout your career if you are a network engineer. See, I've learned CCNA 13 years back. Yeah, so 2011 or 10, kind of that is the time period where I started learning CCNA. Any newer technologies that I'm learning right now. Okay, maybe it can be any network automation or SD-WAN, whatever it is. Right, always I refer to this OSI model. So which means this class is going to be the foundation for the whole networking career. If you guys gonna become a network engineer in future or any network related roles, OSI model is going to be the foundation, right? So I want you guys to listen to me carefully. So we cannot understand the complete OSI model in one session because 2 hours will not be sufficient to understand the OSI model. OSI model is itself a big course, right? Throughout the course, as I told you, right? OSI model is something that you'll be learning every day. So today I'm just going to give you a very brief understanding about how computers talk with the help of OSI model. Okay. So don't expect the complete understanding in this class itself because the nature of the topic is like that. OSI model can't be understood in the first session, or it cannot be, you cannot understand it in the one session, right? So to take time. So once you complete this 15 classes, you'll be able to understand to some extent how OSI model works. But again, you have to learn higher level certification, CCNA, this first beginning level. Next, you have something called CCNP, okay, which is the professional level, and CCIE. Okay. So only when you go to the point of CCIE, that is where you will be able to completely understand and relate everything that works in OSI model. Okay, anyway, so we'll get started. So it's going to be the last class we discussed about introduction networking. That was the first technical session, but this is the actual we are just getting into the networking now only, right? Because that was just a basic introduction to networking, which most of the guys know what networking is. Now only we're gonna start learning the networking core concepts. Okay, so let me take the image first, just to explain. Okay, so here few guys might have learned about OSI model already. If not, no issues at all. Right? As I told you, this course is going to be completely from the scratch only, right? Even if you are a non-technical person coming from a different background, no issues. You can start learning from here. I'm just going to start everything from the basics only. Okay, so what is OSI model? OSI model is nothing but an approach, right? When computers talk to each other, right? Let's say you have PC one here that's talking to PC two. Okay. So they cannot just like that talk, right? Humans, we have intelligence. One person, one human can talk to other human easily because we have intelligence. But computers, since they are just a machine, right, they cannot talk just like that. So how can we make the computers talk to each other? What type of approach we can take? What are the things that is need to be done? What are the facilities we have to give to the devices? Right? Those things are basically we're gonna cover in the OSI model. OSI model is nothing but the approach that humans decided on how computers can talk to each other, right? It's just a model, it's just a reference model or an approach. Okay, so yes, we'll start understanding what OSI model is. So OSI model is going to have seven layers, starting from layer 7. This is the, even though you see the application layer first, but this layer is called as layer 7, right? And then we're going to have layer 6, layer 5, 4, 3, 2, 1. So we're going to have the physical layer at the bottom, which is going to be a layer 1, and we have layer 7, which is the application layer, which is at the top. Okay, so now let me draw a line here. Okay, so what this line basically says is, right, the first three layers of OSI model, right, it's not really important for networking people, right? So application, presentation, session, they are not important for networking people. They are basically for you can think like a developer, a programmer. Those guys are the ones who are gonna concerned about the first three layers of OSI model. As a network engineer, we're not gonna worry about the first three layers. It's not for us. Okay, I can simply give you an example like this, guys. Right? See, now, what is the role of network engineer? What is the role of networking? Right? Share data, right? Maybe if you send some data, if you want to have, if you have some data in your PC, if you want to share it with others, or if you have some data on your phone, if you want to share it with others, you use networking, right? So the same way, I think about 20, 30 years back, right, when there was no internet and all, still people were communicating, right? 30 years back or 40 years back and all, how people were communicating. Now we use WhatsApp, we use mail, we have many networking platforms, social media platforms, we talk. But just think about 40 years back or 30 years back, how people used to communicate. Okay, so they used to put letters, right? We all remember that writing a letter. If you want to say some information to someone, we write a letter, and that letter will take some time to reach the destination person, and he'll again reply back, and it will take some time to come back to us, right? So that is how communication was happening 30, 40 years back and all. So in that communication, when in the case of letter, right, the letter is basically delivered by what department? Maybe you can call it postal department. Okay. So post, or maybe you can simply call it as postman, right? Postman is the one who deals with the letters, right? He goes to the destination, delivers the letter and all. Like we are taking the same role, right? What postal departments were doing, 40 years, 30 years back or 20 years back, we as a network engineer, we are taking the same role, but we are doing the communication through computer, right? So no one is writing letters and all nowadays, right? We simply send a message through WhatsApp. But who creates the platform, right? WhatsApp is just an application. How the applications talk to each other with the help of the network, right? So now, as a network engineer, we are modern postmen, right? We are a technical computer postman. That is what I generally call a network engineer. A network engineer's role is what? Nothing but what postman was doing 20, 30 years back. That is what we are doing right now with the help of computers, routers, switches, and all. So if you think about a postman, right, what postman is really worried about? Okay, let's say postman got a letter. Okay, so just go back 30 years back. You postman has got a letter. Okay, so the postman has got a letter. So we all know how the letter format looks like. So the letter is going to have from, it's going to have to, and it's going to have the subject. Okay, yeah. So now if you take this letter, this is the letter we all know, right? This is how the letter looks like. So in this, the postman takes this letter, and which field is important for the postman? For example, from address to address, and then the subject of the letter, right? Do you think that the postman is really worried about the subject of the letter? Right? Maybe it is a good news, or it's a bad news, right? Do you think the postman is really worried about what type of the subject it is? It is a good news or a bad news? Not, right? The postman never cares about what the subject is. He doesn't care about what the subject, what the data is, right? The postman is really concerned about what? The from address, right? Where it is coming from. And he's even more concerned about the to address, right? Where the letter have to be delivered, right? So he will try to deliver the letter to the to address, right? This is very important for the postman, right? Maybe if the to address the person is not available, then he need to return it back. He need to return it back to the sender, right? The from person. So postmans or postal departments, how they are really worried about from address and to address, and they are not really worried about the subject. The same way as a network engineer, right? We not gonna worry about the first three layers, right? It's like, the subject of this is exactly what we call the data that the user is sending. We're not gonna really worry about the first three layers, right? Can you relate, guys? Maybe if you couldn't relate it completely, that's fine, right? So day by day, once you start learning networking every day, you automatically these things will come into your mind. So the simple thing is subject is not important for the postman or postal department. The same way, as a network engineer, we are not really worried about the first three layers. Okay. So now, like in letters, when someone's writing a letter, we have a field like subject. We give them a name like a subject. We call them as from and to address. But in networking, right, how this has been changed is, right, we're not going to call it as a subject, right? Instead, we're going to call it as a payload. Okay. So what is payload? Whatever the user sends, that is what the payload, right? If you take WhatsApp, right, and you're typing hi and you're sending it, what is the payload there? Hi is the payload, right? So what the user is trying to send, that is what we're going to call it as payload. Maybe the user can upload an image, right? In that case, what is the payload? Right? Image is a payload. So whatever the user can make a voice call, the user can send a voice note, the user can send an image, you can send a hi message or text message, whatever it is, whatever the user wanted to transfer, right? That particular data is what we're going to call it as payload. So we're going to give the name generically as payload. We're not going to call it as text message. We're not going to call it as an image. We're not going to call it as a voice note. We're not going to give them different names on what he's trying to send. According to us, let it be anything, right? It can even be an encrypted data. It can even be an encrypted image, right? It doesn't matter. According to us, it is nothing but a payload, right? So this is the name that we're going to give. So in letter, how you have subject or the data, the main portion, right? The main body of the letter. Here we're going to call that as in networking or in computers, we're going to call it as a payload. Okay, so this guy, right? What these guys are. So this is from and to. What's the name that we're going to give to these guys? In networking, we call them as headers. Okay, so headers. Right, if you guys have any doubts, you can ask me after the class. Maybe you can personally ping me or mail me. I cannot respond to the doubts because the audience is huge. We cannot clear doubts to each and everyone one by one. So the session will get over. So yes, I'm just going ahead. I can see if you guys are raising hands, guys. If you have doubts, I'm not gonna answer your doubts. Please raise hand. Maybe you don't have to raise hand. You can just listen to me. Whatever doubts you get, please wait, listen to the classes. Maybe your doubts might get cleared in a few minutes, Or if it doesn't get clear, then you can ping me in WhatsApp or you can mail me. I'll respond over there. Okay. So yes, so headers. So two portions are there. So a letter has got two portions. One is header, the other one is payload. Right. So from one to these guys are important for networking people, right? Like this is important for Postman, right? The same way headers are important for networking people. The same way the networking people, they are not really worried about the subject, because how Postman doesn't worry about the subject, we're not going to worry about the subject, right? So since calling it as a subject, we're going to give a name called payload. Okay. So here we give a name called letter, right? So here we call that as a letter. Here is the letter. What name we have for this? Right. So because the names are keep changing, right? Subject, we don't call it as a subject, we call it as a payload. From and to others, we don't call it as from and to, we call it as a header. Right. Then if it is a letter, we're not going to call it as letter, we're going to call it as a packet. Got the point? Packet. So very clear. So packet is what? The packet consists of what? Packet consists of headers and then payload. Right? How what a letter consists of? Letter consists of from address to address and then subject. But packet in networking, in computers, we don't call it as a letter and all. Computers don't send letters. Computers will send packets. Right? In that packets, you will have headers and then you will have payloads. Okay. Yeah. So now let me erase this. Okay. Good. So now let's understand the first three layers. What they're going to do is they're going to give us the payload, right? They are the one which is responsible for the payload. Okay, let's just point this guy as a payload, or you can simply call it as a payload, or maybe if you want, you can simply call it as a message also. Right? You can call it as a message, or you can call it as a payload. Payload is a right technical term to use. Okay, it's a payload. Okay, now fine. The first three layers, we're not going to worry about it. We're not going to spend time on them, right? Application, presentation, session, right? These names are sufficient for a network engineer, right? Even you, when you go for any networking interviews and all, no one is going to ask you more about the application, presentation, session and all, right? The most of the networking interviews will be happening in the below layers. Okay, yeah. So now, what transport layer is responsible for? So the first three layers, what they do is, okay, let me just go and erase this and write it nearby. Okay, so the first three layers give us the payload. Okay, what the payload is? The payload can be anything. It can be a message, it can be text message, payload. It can be a data, it can be a voice note, whatever it is. Okay, so here, what transport layer? So once the first three layers, they generate the payload, they'll give it to the next layer called transport layer. See, we call them as layers. Okay, we use a name called layer. So this is application layer, presentation layer, session layer, transport layer. So what is layer? Layer means it's nothing but a cover. Okay, so we all know what is layers. Layers means just something that is covering, right? So when you have layers, you say that it is covering something. So here we call this a layer because what they do is, or how networking basically works is, right? Here, once these three layers, once they give the payload, what transport layer will do is, it will add a cover. Okay, that's what transport. So now the payload is given to the transport layer. What transport layer does is, it adds a new cover to the payload. Okay. Yes. So now what you're gonna add is, you're gonna add the headers. Okay. So you're gonna add the headers. So what headers and all we have in the transport layer? Okay, see, transport layer basically deals with two protocols, guys. Okay, one is TCP, the other one is UDP. Okay, so transmission control protocol, UDP, user datagram protocol. So these are the two protocols that works on transport layer. And now this TCP or UDP, depending on whatever communication you use, the headers will be filled. Right. Let me come back to this headers in a few minutes. Now let me give you a very brief understanding about what is TCP, in which case we need to use it, and what is UDP and all. Okay, let me take a different slide to explain that. Okay. So now let's understand this way. Let's take a simple communication. Have a PC here, right? And I have a server here, right? So assume that this is Google server, google.com server that is in USA. Okay, and I'm in Chennai. Okay, so I'm in Chennai. Yes. So now I need to contact this google.com server that is in USA. I'm just requesting for a web page. So what I generally do, I go to my PC and type www.google.com, right? So once you type google.com, so some DNS behind the scenes DNS will happen. We'll talk about DNS and all later. That we have it on a separate day. So once the DNS, that process is over, right? We'll just skip the DNS part. So what happens exactly is, guys, now the PC will try to know the IP address of Google server. That is what DNS happens, right? After knowing the IP address of the Google server, now the PC will send a request to the router that it has got. See, we all have no routers at home. Maybe if you don't have a router, if you're joining from mobile data, then again, even if you're joining from mobile data also, your mobile data provider, right, whoever it is, Jio or Apple, whoever it is, that guy will have a router in this side. Anyway, routers are very important to transfer the data. If you're having a broadband connection, you have a router at your home. If you don't have a broadband connection, if you're joining this session from mobile data, assume that your PC, sorry, your phone is sending a packet to the router, which is maintained by your service provider, right? It can be Geo or Airtel or whoever it is. Okay, let's simply take it like a home network example, please. Don't think about mobile networks and all. Just think about a home network. You have a Wi-Fi connection at your home. So in that case, you have a router at your home, right? So now once I type, google.com, after knowing the IP address of google.com, I'll just go and send the request to my home router, right? So this guy, if I put R, then it's nothing but a router. So it's a home router. So now my home router is connected to another router that is maintained by ISP. Okay. So this ISP could be whoever, right? If you take connection from Geo, then he is your ISP. If you take from Airtel, then he is your ISP, right? I'm here taking it from a company called Hathway. Okay, that is what the ISP I have here. So in my case, so it just goes to the Hathway ISP. So from there, what happens is again it goes to again R circle means router. Again, this is ISP1. That ISP1 will forward my request to ISP2. Right? Maybe this could be Hathway. This could be some other ISP also. We don't really need to know who that guy is, right? But understand it is also a service provider. It can be geo-based or it can be from a different country, right? Maybe if you see, I don't know how many of you are joining from Gulf countries. In Gulf countries, there is a very popular service provider called Orido. I think my spelling is correct. So he is very popular in Gulf countries. It could be right. It could be that way also. So, but the simplest point that you have to understand is all these ISPs are connected in some way, right? So I take Hathway ISP, forwarding it to the other ISP router. That other ISP router will, so which what happens is my query, my request, it goes all the way from here, and assume that this guy is ISP N. Okay, so hardly when you travel to USA, right? If your request is traveling to USA, somewhere around 10 to 15 service provider network you have to cross, like Hathway, Geo, or maybe Orido, or some other ISPs in different countries, right? You have to jump, you have to hop multiple routers, which is maintained by every ISP, and finally, you will be reaching. Okay, assume that this is ISP-N, right? And Google Office also will have a router, right? There is a router in Google Office also that is maintained by Google itself, right? We'll call it as Google Office router. Okay, again. So this is how they are connected. Now understand, this query goes from all the way from here, and then it goes, it goes over here. It crosses from Chennai to USA, somewhere around, I think, 15,000 kilometers. Our packet is traveling, right? Packet. We have to call it as a packet because we don't call letters anymore in networking. We call it as a packet. So my packet travels from PC to USA server, 15,000 kilometers it is crossing and reaching the Google server that is in USA. Right now, once this guy gets my again, few guys might have, okay, how the communication is happening. Is it through satellite? No, guys, right? So majority of the communication that we are making right now is through cables only. Okay, so it's through C cables, right? You have C cables. You can just go to YouTube and search for C cables. You'll be getting hundreds of videos. You can understand all the continents that we have, all the countries, all the states. They are completely, connected with cables. We all know that. Okay, so sea cable is the one which, if you want to cross the continent, of course, there are cables in sea. And if you want to cross countries in the same continent, maybe, of course, there will be some cables that is laid under the underground. So cable connection only, right? I mean by cable connection, not satellite, which means your traffic, your packet is traveling from your home router all the way through cables. It is traveling to Google server that is in USA. Okay. So now the Google server that is in USA understood that someone is requesting, or someone from Chennai is requesting for the web page. So what Google server will do? He will respond, right? Okay, because he need to give the page to this guy because he needs it. Okay, now what is the size of a Google web page? Let's understand that first. Okay, so the size of the Google web page is somewhere around 300 KB of data. 300 KB. Yeah, that is what the size of a Google web page is. When you download a movie or when you watch movie in Prime or Hotstar, in the metadata of the movie itself, it is mentioned that this movie will take 5 GB of your data. or this movie will take 1 GB of your data. Or even if you download movies, let's take that way. So when you download a movie, you have seen this movie is 2 GB or 10 GB, right? When you download a song, you see that this song is 10 MB and all. Yeah, so every data has got some size. Every even it's a web page or a song or a movie, whatever it is, right? Everything has got a size. Now the size of a Google web page is 300 KB. So now the catch here is this 300 KB of data cannot be transferred in a single attempt. So what I'm trying to say is, let's say the 300 KB of data is what the Google server have to transfer. So according to us, you might think that 300 KB of data is a small data, but no, back then, if you think of 50 years back, and that is where networking started. So 1970s, that is where networking protocols were invented. That is where the starting stage of internet is. So in those days and all, 300 KB of data used to be a big data only. Right now, 300 KB is small for us. 300 KB, we just next to KB we have MB guys. Next to MB we have GB. Right? We are talking in terms of GB now. So it is not MB, it is just KB. So for us, 300 KB of data can be huge data, but these networking protocols, networking concepts are designed in 1970s. No, those days and all, 300 KB of data used to be a huge data only. So what they thought is, right, 300 KB of data cannot be transferred. Okay, so they want the 300 KB of data to be cut into multiple small data. So this is what even exactly we follow now also, right? So now 300 KB cannot be sent. So what generally the server will do is, if the size of the Google web page is 300 KB, then the maximum data you can send in a packet, right? So we all know packet is what's gonna go from here to here. So the maximum size of a packet is just 1.5 KB. In a packet, you can dump only 1.5 KB of data. Got it? So in a packet, you can dump only 1.5 KB of data. In that case, what happens? Right. So if you want to transfer this 300 KB of data, you cannot transfer it just like this in a single packet. You want to cut it, right? So this operation is done by the server itself. You're going to cut this packet into multiple small, tiny chunks, right? And each packet, what is the size? A packet can carry maximum 1.5 KB of data. Now, how many packets are required? 200 packets. Okay, 200 packets, right? So 200 into 1.5 KB, it's a simple mathematics that you totally get 300 KB of data, right? Okay, now what Google decided is, since he wanted to transfer the 300 KB of data, which is nothing but a Google web page, he cannot transfer it just like that. He need to make that into 200 small portions. And all 200 small portions will have 1.5 KB of data. So now he'll be transferring packet number 1. Okay. So this is, assume this is packet number 1, and this is packet number 2, this is packet number, this is packet number 4, and this is packet number 200. That way, this guy transfers packet number 1, and then this guy packet number 2, he'll be transferring all packet number 3, all he'll be transferring, and finally packet number 200. So once he transfers all the 200 packets, when all the 200 packets comes to this particular PC, okay. So my PC, what my PC will do, all the packets will come from here. All the packets will come all the way from Google server to Chennai PC. All 200 packets, one by one, they'll be coming from Google to from USA to Chennai, from Google server to my PC. Once I get all the 200 packets, what happens is the PC on this side will assemble the 200 packets together, and he shows that as a Google web page. Okay. So now you got the point. So there you have a Google web page. That Google web page is 300 KB of data, but that 300 KB of data cannot be sent in a single packet. So you're gonna have 200 packets into 1.5 KB, right? So this 1.5 KB is what we call as MTU, maximum transmission unit, right? You cannot send a packet more than 1.5 KB in our traditional internet network. Okay. Yes. So he just sends all 200 packets, and all 200 packets will be again reorganized or reassembled on the client side, and you see the Google web page. Clear? Okay. Now, what could be a problem in this case is, since the packet have to travel 1,500 kilometers, right? Sorry, 15,000 kilometers. Okay, it have to travel from all the 200 packets have to travel, right? They are just traveling from here. 200 packets are traveling to the Chennai PC. The distance is 15,000 kilometers. Now there is a chance of packet loss. Okay, since the packet was sent, there can also be a chance of packet loss, right? Okay, so generally, the general internet survey says that there is always 1% packet loss, or maybe less than 1%, but we'll have it as 1%, close to 1%. Okay, so 1% packet loss is happening. In that case, what happens? I'm sending 200 packets. In the 200 packets, If it is 1%, then what happens? Only 198 packets will go to the PC. What happens to 2 packets, which is 1%? 2 packets are got dropped somewhere in between. Okay, so because this is a survey, right? Because whatever you send, it have to travel from here to here. No, there could be some router issue, there could be some cable issue, right? There are many reasons that these 2 packets can get dropped, right? Don't deep dive into what are the reasons that the packet loss can happen. Don't worry about it, right? Generally, packet loss happens, guys. So 1% of packet loss happens means in this 200 packets, or in this 200 packets, only 198 packets reaches the PC. The other 2 packets which is lost. Now, what if these 2 packets are, they contribute to the search box? Assume that this 200 packets or the one, sorry, these 2 packets are the one which has got search box inside it, right? It's just a packet, right? It has got a search box inside it. Now I got a 198 packet. Now my PC is just showing me this 198 packet, but which doesn't have what? Which doesn't have these 2 packets. Assume what if these 2 packets are supposed to be, search box packets? Now what I couldn't see in my Google page, I'm seeing my Google page like this, guys. My Google page is there. The Google logo is there. Okay, everything is nice, but you don't see the search box, right? There you see the search button and sign information. Those things are there. But what is the use? Okay, the search box is missing because why? Because these packets were dropped. Since these packets were dropped, the search box is missing. Now, can we do anything with a Google web page which doesn't have a search box with this? No, right? There is no need. There is no use of getting a page without a search box. Now, what we do? So generally, we make a refresh, correct? We just make a refresh. So if you do refresh also, again, what happens, guys? Again, you are requesting, again, this guy will take the 300 KB, cut them into multiple small, tiny chunks or tiny pieces, and he will send it again to you, all the 200 packets. Maybe this time, again, you will be getting how much? Only 198 packets only. This time, you may get search box successfully, but you are not getting the Google logo, or you're not getting sign in button. Something will be missing, right? Can you understand what I'm trying to say, guys? Okay, so you're just getting a Google page. In the Google page, always 2 packets are missing. One time search box is missing. Again, you refresh. Next time search button is missing. Again, you refresh. Next time Google logo is missing. You refresh, right? You cannot keep doing it, right? So we want reliability. What is not there, right? We cannot rely whether what we get from the Google server is 100% or not. We don't know, right? If it is 1% or if it is 2% data loss, then we are missing Google. We are missing few portions of the web page, correct? Okay, so then how do we fix it? Yeah, so that is where we really need this protocol, which is TCP. Right? So TCP deals with reliability. Okay, so I told you 2 protocols are there in transport layer. One is TCP, the other one is UDP. Okay, TCP means transmission control protocol. This protocol is designed in such a way that we'll talk more about TCP, maybe not basically in this course, I guess, because we don't have time to discuss TCP in depth in this course and all. But generally, in my CCNA course, the full course, I'll be discussing more about TCP now. But here, again, 20%, 25% of CCNA is what I'm planning to cover over here. So we'll see. If time permits, I'll discuss about TCP also in one class. But don't, I'm not going to guarantee that. Okay, yes. So what TCP basically does is, right, we'll understand a little bit of TCP, not in depth in today's class. Okay, so every time, assume that I'm just going to undo everything. Yeah, so yes. This is the maximum undo I can do. So let me erase this. Okay, yeah. Now what happens is this guy server sends packet number 1. Right now, once the packet number 1 reaches, it just have to go to this guy this way, and it need to reach here. And once PC gets the packet 1, what happens is this guy will have to acknowledge, right? He'll acknowledge. Acknowledge means what? I received acknowledgement, right? Like wherever you go, whatever you purchase, they give a bill, right? That's an acknowledgement. The same way, this guy will acknowledge. He says, hey, server, thanks for packet number 1. I received it. Now, this acknowledgement will again come over from here, and the acknowledgement will reach the server. Once the acknowledgement, again, see, packet is traveling from Google server to PC. Again, acknowledgement is traveling from PC to Google server. Again, what happens is, this guy, once he get an acknowledgement, the server is happy. Right? See, whatever I send you, you received it, right? I'm happy. Now let me send packet number 2. Now again, right, once this packet number 2 have to again travel all the way from here to here, and then again PC received it. Now this guy will receive acknowledge for packet number 2. Hey, server, acknowledgement received packet number 2. So now they'll be keep doing it, right? And the server is happy, right? Because he's getting acknowledgement. Okay, so here, assume that he is sending 100 packets. Okay, and all the 100 packets acknowledgement came. Okay, let's assume that packet number 101, which has been lost, right? The packet number 101 is traveling somewhere in the Arabian Sea or somewhere, I don't know. It got dropped. Okay, So now will the PC acknowledge for this packet which he didn't receive? Okay, you're not going to acknowledge, right? You're not going to acknowledge. The last acknowledgement he gave was 100 only, which he received it. But if you see packet number 101, he didn't receive it, right? In that case, what happens? This guy will not acknowledge. The server is waiting. The server is expecting an acknowledgement from the client, but the client means this guy. Okay, this guy is a client, this guy is a server. Okay, so now the server is expecting an acknowledgement from the client, but the client is not acknowledging. Because why? Because he didn't receive it. Now the server is intelligent enough to understand that, okay, if I didn't get acknowledgement 101, then what should I do? The PC didn't receive it. So what I'll do, I'll retransmit again. I'm just going to retransmit. Automatically, it'll retransmit. Which packet alone? The packet number 101 alone, not all the packets, just 101 packet. Now he's retransmitting it. Now this time, this 101 rate, possibly it reaches this PC. Now what happens? The PC will say, hey server, received, acknowledgement 101 received. So now the server is happy. Now this process keeps happening. Is wherever the packet loss happens, as you know, again you send packet number 102 acknowledgement received, right? Again you send, you just keep sending, and finally you send packet number 190. Again that got dropped. Again what happens? This guy will not acknowledge. Again 190 will be retransmitted. Packet number, I'm talking about packet number 190. So totally all 200 packets are transmitted. So whichever packet get dropped, those packets are retransmitted. This packet got dropped somewhere in between. For some reason it got dropped, and this guy got dropped. So what happened? They are retransmitted. Right. So if there is a packet loss, the TCP protocol is designed in such a way, very intelligently, that the client and server will know, or the PC and the server will know, that the packet loss has happened, and they have to retransmit it. So they retransmit it so that the client gets it. Now what happens is, so now this guy, anyway, he'll be getting all the 200 packets without any problem. Even there is a packet loss, since this guy is not acknowledging, this guy is retransmitting it. Right? So this is what TCP is. TCP is a wonderful protocol, and almost you can think about any application right nowadays. You can think about any application, Facebook, Instagram, WhatsApp, or whatever it is. You think about a browser or whatever it is. Right? Everything works on, most of the applications are working on TCP only, right? So you go to web page, that is TCP, right? You send a message in WhatsApp, that's TCP, right? You go to Instagram, you just scroll the wall, or you just go to you go to Reels, and you just scroll the Reels, right? TCP, everything is happening through TCP. Right? TCP is widely used protocol. I can say 90% of the internet applications are based on TCP based services, what they are using. Okay, you can think about any application, web page, WhatsApp, whatever it is, TCP based on it, because it's very good, right? It's acknowledging, right? If there is no acknowledgement coming, then it will retransmit it. Okay. What if how you want me guys to be? Okay, so I'm a trainer here. So if you guys are not understanding something, or whatever I say, right? If you guys are not getting it, and you guys are not acknowledging me, then what I should do? I need to again retransmit. Let's say I just took OSI model for 1 day, for 2 hours, and finally someone says, "Sir, I didn't understand anything from your OSI model. Can you retransmit it?" Yes, of course, I take one more session for him alone, right? So even people like me, if I'm TCP based, right? Okay, TCP reliability, right? If someone didn't get it, I need to again retransmit it. Again, he didn't get it, I need to retransmit it, right? That's what on TCP is. Okay, now let's talk about the other protocol, which is the other 10%, I can say. Okay, the other 10%, which is UDP, User Datagram Protocol. Okay, so user datagram protocol. So what is user datagram protocol? Again, the same thing is, nothing changes, right? The packet size 1.5 KB, everything is same only. But what happens is, there is no acknowledgement. The server will keep sending, and if the client received or not, the server will never care about it, right? The server never cares about the acknowledgements, and the client will not even acknowledge it. That is what. So the communication is a little bit strange, right? The servers keep sending, guys. We'll send. The client receives it, he is happy. The client will never say to the server that I received your packet. Right? That's a strange conversation, strange communication, but that is what UDP is. Right? UDP doesn't have acknowledgement. So since there is no acknowledgement, what is also not there? Since no acknowledgements, no retransmission. Right? Only if you acknowledge, only then you can have retransmission happening, right? If there is no acknowledge, there is no retransmission also. Okay. So in which case, UDP can be used. UDP can be used. Which case? Okay. I know you guys cannot answer because chat is also disabled. You cannot unmute, I know. But anyway, it's a way of asking question ways. I'll answer anyway. So where UDP will be used? UDP will be used in cases like, Very good example in front of you. Online meetings, for example, Zoom session you can take, right? You guys are on Zoom right now. I'm in Zoom, right? We guys are on Zoom. Online meetings. So see, just assume now, guys, UDP. Whatever I send, if that got dropped, let's say, no, my internet is not working properly. I know I'm just saying, and that 10 seconds of my conversation, right? 10 seconds of my conversation got disturbed. Okay, assume like this. I'm saying, and something like that happened, and you're not listening to me clearly. And that is a packet drop, correct? So whatever I say, if you guys are not really getting my point, or if you guys are not getting what I'm saying, if there is a packet loss, then is it okay for you guys to have the 10 seconds in the next minute of the class? Okay, I'm saying something, guys, got disconnected. Okay. And that disconnected 10 seconds of voice, my voice, can it come in the next minute of the conversation? Is it okay for you guys? Or can it come in the next 10 seconds? Or can it come after 10 seconds of the conversation? No, right? It confuses. Just think about it. I'm saying something. I told something. You guys didn't get it. But is it okay that if you get it on the next minute of the conversation or after a few seconds of the conversation? No, it'll confuse the complete the purpose of having this meeting. So all something, anything that you can think about live, anything that we do in live. For example, it could be a YouTube live, it could be Zoom meeting. It could be, if you're watching a match in Hotstar or Geo Cinema, whatever it is, right? These live streaming content are always on UDP only. If there is something packet loss is happening, automatically, we don't have to really retransmit it, right? So if the packet loss happens, then let it be, let it, okay, right? Let it leave the packet loss. Let's just focus on what is gonna come upcoming. Okay, so live is always a best example for UDP. Okay, so UDP always works on, or live conversation always works on UDP, right? And I believe, you make a WhatsApp call, just see if you take WhatsApp as an application, right? WhatsApp chat, that particular service works under TCP, guys. It's a TCP, okay? And WhatsApp call, let's say, WhatsApp call, right? It could be a video or voice call, video, voice or a video call. That is again what? It is again UDP. You got the point? So every application works on UDP as well as on TCP. The Zoom meeting also. So the chat, right? If you send a chat to me, that's TCP. But whatever I say, that is UDP. Got the point? Okay. Now, just to make you guys interesting towards the session, I'll just go and use this application Wireshark. Anyway, I'll talk about this application later in the course. It's a packet capture base. So whatever packet I'm sending, it's gonna capture and show you. Uh, yeah, so I'll just go and make a capture on this Wi-Fi interface. Can you see right now I'm in the Zoom meeting, right? And can you see, guys, most of the packet that you see was got what protocol? UDP. Because why? Because I'm in Zoom meeting. So once I end the Zoom meeting, I'll not be able to see these many UDP packets are going on. So what these packets are having? What are they having? They are having my screen sharing. They are having my voice, right? Which is what you guys are getting. These are the packets, right? So about these things and all, we'll definitely understand in upcoming classes. It's a short class, I know, but I'll try to give maximum I can. Okay, we'll talk about Wireshark captures and all later in upcoming class. Guys, I have a separate day. Once we start the NG labs, before that, I'll discuss about this Wireshark and all. Okay, Wireshark, right? So you guys came to know about a application called Wireshark. What is this? Just go and search in the internet about what Wireshark is. Today's assignment this is. It's nothing but a packet capture. It's a nice thing, whatever packet that your PC is sending, you can just capture and see what is inside it. Okay. Yes. Okay, so yes, now let's go to the OSI model back. So now we understood a couple of things. One is TCP, we understood, the other one is UDP. Okay, yeah, so TCP and UDP, TCP is reliable and UDP is unreliable. It depending on what type of service you are accessing. As I told you, if you take WhatsApp and if you're sending a hi message in chat, what protocol will be used? TCP, right? Maybe you are just making a call to someone in WhatsApp. What is it? UDP. For the point, the same way, if you are opening browser and if you're going to Google, that is TCP. If you're opening browser, going to Geo Cinemas, and then in Geo Cinemas, if there is some live matches are going on, if you're watching that, that is again UDP, right? So don't think like, web browsers are always TCP, not like that. Web browsers, like, you can have TCP, you can have UDP, right? So Google web page is TCP, whereas Geo Cinemas or streaming contents are UDP. Okay, so yes, so that way, these are the headers, right? So we're gonna have, so depending on what type of internet application that we are using, right? The headers will be there. So either it can be what it can be. If it is TCP protocol, then you're gonna have TCP headers, or if it is UDP, then you're gonna have a UDP headers. UDP headers. Okay, see, OSI model class will be theoretical only, guys. We cannot do anything, but this is important. I know 2 hours of theoretical session, no looking at the monitor stuff, but just resist and attend this session completely, because from next class we're gonna do the labs also, right? I'll be doing the labs, I'll be explaining, so I can make that session more interesting than this session. But OSI model is theoretical class only, but that gives you a very strong foundation. So I want you guys to resist from the meeting. Don't leave the meeting because it's boring and all. It's not actually boring, right? If you guys listen to me, it is interesting only. Yeah. So now let's come back to this transport layer. So what transport layer does? Transport layer puts a new cover. Arutimiri, please don't raise your hand. I cannot answer your questions right now. You can ask your question later in WhatsApp, right? Don't keep raising your hands, please. Yeah, because I can understand I cannot answer questions right now, because if we start giving permission to unmute, everyone will start unmute and ask their question. Right? Let's make this session clean, and whatever doubts you have off the record, we can discuss it. Okay, so what transport layer does it? It just adds the headers. For example, what and all headers will be added? So it's a new cover, understood? So the payload is there, and above the payload, there is a new cover that has been added. Okay, it's a new cover. It's like a gift, guys. Just think about you think about a gift. You have a gift, no? And will you give a gift just like that? No. What we do? We put the gift inside a box, correct? Now, what is what if anyone sees that, what they'll be able to see? Will they be able to see the gift? No, they'll be able to see what? They'll be able to see they'll be able to see the box only. Because why? Because the box is covering the gift. Right now, box is a layer that is covering the gift. Now, will I give the box just like that to someone who I'm just presenting that gift? No. What I'll do? I'll just go and wrap it, right? I'm just going to put a nice color wrapper in it. Now, what someone from outside can see? They can see a colorful wrapper. Okay, now you gave the gift to that person. Now, what happens? That person, what he'll do, right? Will he be able to see the gift, or will he be able to see the box? No. What he'll be able to see? He'll be able to see the wrapper, because that is the first layer. Okay. After opening the wrapper, then what that person will be able to see? The box. After opening the box, only that person will be able to see the gift, right? So this is what we call as encapsulation. Encapsulation means, right? So when you give something, you just don't give that just like that. You put a cover on it, so that the receiver person have to decapsulate. You need to remove it, right? He or she need to remove it, right? You need to remove the wrapper first. That is decapsulation. And again, you need to remove the box, and then he'll be able to see the gift. Encapsulation, gift. After that, a box, a new layer. After that, a wrapper, new layer. Decapsulation, removing the wrapper, removing the box, and then you see the gift, right? So that way, that is what the core idea of this OSI model also. So now we got a payload, right? The payload is now covered. Now it's a cover. It's a new cover that has been added above the payload. Now the payload is hidden. The payload is inside this cover. And now what will be what you will have in this cover case? You're gonna have a layer 4, or you can say layer 4. You can call it as, because this is layer 4. No, you can call it layer 4 header. Simply, I'll say it like layer 4 headers. Right? I'm not going to use it as transport layer base because that is not the right. I mean, that is not actually in industry people uses. People will never say transport layer or network layer. They know it's transport layer, network layer, but they always refer to layer 4 or layer 3 or layer 2. They refer like that only. Okay, so layer 4 headers are there. Example, what are the examples of layer 4 header? What and all will be added over there? For example, something called sequence number. Okay, something called acknowledgement numbers, right? Because these things are important for sequencing and acknowledging, right? Those headers are there. And also one more thing, port numbers. Okay, in port numbers, you can think like source port and destination port. Okay, yeah. So these are the headers that we're gonna have. Like this, there are a few more also, right? I didn't write every header of layer 4. So now there is going to be a new cover that has been added. In that, we're gonna have destination port, source port, sequence number, acknowledge number, and then few more also, right? Just try to understand, guys. If it is still confusing, no issues at all. Okay, so you can watch the recording and you can understand it again. And if you guys have asked me about the recordings, they keep asking me in the chats and all. See, recordings I'll share, but not in the not until the boot camp gets over, right? Once 15 sessions are over, right? All the 15 sessions I'm recording it. But altogether, at last, I'll upload and I'll give access to the recording, right? Because if you give recordings, people will not attend the live classes. So recorded sessions, we'll record it, we'll have it with ourselves. Once the 15 days boot camp is over, I'll put the chat in the I'll put the message in the group, in our WhatsApp group. You guys can freely purchase this 15 days of recording sessions. You got the point? Okay, so recordings cannot be shared during the sessions, right? Once the boot camp is over, all 15 days of classes together, you can access it for free. Okay, yeah. So now let's understand the next layer. Okay, what is transport layer? We just understood now. Next is network layer. So again, the same concept. Concept doesn't change. The concept is the same thing. This guy was trying to add few headers now. Now after adding that cover, this transport layer will give to the network layer. What network layer is going to do? He again going to add a new cover. That is what the layer is. Network layer. Layer means new cover will be added. Okay, new cover is added. Okay, layer 3 cover it is, right? This is layer 3 header. Okay, just layer 3 cover I can say. Okay, I'll put this layer 4 cover. In layer 4 cover, I'll just rename it as cover. In layer 4 cover, you have these headers. These are the headers. Okay, like what is the example I gave in the letter from address and to address? Where is that example went? I don't know. I erased it, but hope you guys can understand. Right? In the letter from and to or headers, the same way in our packet, we're gonna have layer 4 cover. There is a separate cover for layer 4, a transport layer. In that layer, we're gonna have headers like this, right? Okay, now layer 3 cover. Layer 3 cover, it's gonna have its own headers. Okay, and the more important one in network layer is IP addresses, guys. So we all know that PCs can talk only with IP addresses. Even the yesterday's class also I demonstrated between a couple of devices, right? Okay, so now in layer 3 cover, you're gonna have headers like source IP, right? The sender machine's IP address, destination IP, the receiver machine's IP address, right? These are the headers that we're gonna have on the layer 3 cover. And also there is something called TTL, time to live is there. There is something called protocol. Okay, that is also there. Okay, I'll put it like proto. That is there. And checksum is there, right? These are the these are the layer 3 covers. And I'll just put a few more. Okay, few more are there. We're not gonna cover everything about layer 3 and all, but which and all which is very important, right? Like source IP, destination IP, TTL and all we'll be covering. Okay, yes. So yes, so this is the idea. So now the layer 3 has added a new cover. In that cover only we're gonna have source IP, destination IP, TTL and all. Okay, now just believe guys, you are 1.2. Assume you are PC1 and PC2. Okay, PC1 is 1.1 IP address, let's say PC2 is 1.2. Right now, when 1.1 is trying to send a message to 1.2, the source IP field will be what? 1.2, and that is in which cover? That is in late, sorry. 1.1 page. 1.1. Source IP is what? Source IP is 1.1. What is the destination IP? Destination IP is 1.2 because who's sending the packet? PC1 is sending the packet to PC2. So in layer 3 cover, we can see the source IP and destination IP. Right? These packets and all we can see in Wireshark. Right? That's a very very good application, very useful application. I've used Wireshark for a lot of understanding concepts and all. Okay, we'll go through Wireshark application later. But in Wireshark, if you open it and you can see what is the source and destination IPs and all, right? Everything can be seen in Wireshark. You're just gonna open the packet and see what is inside it. Okay. Okay. Now, next thing is data link layer, right? Again, same thing, right? This guy will again add a new cover. It's gonna add a new cover. Okay, let me put in a different color for it. So data link layer 2. So this guy will add a new cover. Okay, how it all started is we start with the payload and then layer 4 cover added by transport layer. So what and all he added? He was adding sequence number, acknowledge number. Even though you guys don't know what these things are, don't worry. We'll discuss about these things and all. Don't worry. Just take it in a very little way, guys. Very lighter way. Because OSI model in the first class, you can understand only in a very lighter way. All you need to understand is nothing but there are multiple covers in a packet, right? So that is what you need to understand. Every cover has got its own specific headers. Okay. Okay. Now we'll take data link layer. Data link layer is nothing but layer 2. It's a layer 2 cover. And that layer to cover has got its own headers. For example, we're gonna have something called source MAC address. Right? There is one more address in the networking. We call the source MAC address. We're gonna there is also one more thing called destination MAC address, and there is something called type. Okay. So yes, so these are the headers that we have in layer to cover. So now you understand how it happens. So the payload was first created like a gift, and the transport layer cover was added, right, like a box, and the network layer cover was added like a wrapper, and now that is put inside a bag, right? That is what data link layer kind of example I'm just trying to give here. Okay, so the gift, this is the gift payload, cover, box, and then wrapper, network layer, and then bag, right? You just put inside the bag, right? Now, can anyone see? No, no one can see. Everyone can see only your bag now. Once you open the bag, they'll be able to see the gift with wrapper. Once they open the wrapper, they'll be able to see the box. Now, after opening the box, they'll be able to see the gift, right? You got the idea? Yeah, very good. Okay, let's try to understand what exactly happens in the physical layer base. See, physical layer, again, we're going to call it as a layer only. Right? This is also, we're going to have a name called layer only. But this physical layer is not adding any covers. Right? What physical layer does is, the duty of physical layer is, in our PC, we have something called network interface card. Every PC has got it. Network interface card. I'll show you the image of network interface card now. Okay, wait. Okay, so this is the network interface card. Okay. Okay, so I'll try to take a screenshot of this. Okay, let us have a small quiz, guys, just to make the session interactive. Okay, I'll create a poll. So yes, so the question, you guys can see the questions once the poll has been launched, or maybe I'll just read out the question. Okay. So, okay, wait. In which layer we have source IP? Okay, that's the question. Wait, let me launch the uh, options. Let me answer the question, please wait. I'm just adding the options over here. For example, it's gonna have it on layer 4. Layer 3 network, or layer 2 data link. Okay. So yes, I'm just going to give you the option. Please choose the right option. And once the poll is done, I'll show you the results and share the results also. Okay. Yes. Okay. Let me save this and then launch right now. Okay. So please go and answer the poll, please. Yeah, really interesting. You know, I'm really happy that you guys are following the classes. I'm talking about source IP. Yes, please, everyone answer. No, I got somewhere around 150 answers only. Please, everyone answer. Just give some options, guys. Let's be interactive. I know you guys cannot unmute and answer. Just answer my poll. Okay. So I think enough we got. I think I got 164 now. 164 answers so far. Okay. So yeah, I think it's going 172 now. I think let me end the poll, please. Okay, let me end the poll. Okay, so I'll just give you the answer also. Okay, I'm just ending the poll. I'm sharing the results. Okay, hope you guys can see the result over there. I think 81% have scored it correct. Others are, 12 transport and then 7 data link. Maybe now you can see my. Let me stop sharing the poll. Okay. Yes, now you can see, where exactly this those IP addresses in layer 3 covered. Okay, network, right? This guy is layer 3. So it is where you have source IP. Got it? Yeah. So very good. At least 80% answered it correctly, right? Okay. Others, I don't know where you got confused. That's okay. Yeah. Yes. So like this, we'll have polls here and there, guys, so that we can have the session interactive. Okay. Now let's talk about this guy. What is network interface card? See, it is a component that is inside our PC, right? This is a component, right? We call this component as network interface card. Every PC has got it. And even in laptop also, you can see there is a LAN port. I don't know how many of you have noticed it in your laptop. There will be a small LAN port, right? So this is a network interface card, and this, this guy. Can you see this? This is what you see here. Okay, this one is what you see here, which means when you open the CPU, you'll be able to see a component like this, right, which we call as network interface card. And the role of this network interface card is very simple, right? He is the one who basically, wait, yeah. So what happens is right now, you have a payload, and then that is covered with layer 4, and that is covered with layer 3, and that is covered with layer 2. Okay. Now this whole, which we called as a packet, right? Now this whole packet is in the PC only, right? It's just in the CPU. It is inside the CPU. Now what happens is our CPU is gonna, our PC or our CPU is gonna transfer, or it's gonna send this packet to this network interface card. And what this network interface card will do is, right now the packet is in what format? What format PCs can understand, right? They can understand only binaries, right? So the PCs can understand only binaries. So right now the packet is full of zeros and ones, right? Even though you send hi message, right? Inside the payload, even though you have hi, but hi is not what the PCs or hi is what not the computers understand. If you know computers a little bit, you can understand. If you type hi message in your in your chat box or in your WhatsApp chat, you according to you only it's high. But what it is nothing but a binary value. Every character has got a binary value, so it's just nothing but a binary, right? Right now our packet is what? It's full of binary on it. Okay, now this binary is given to the network interface card. What this network interface card will do is it will convert this binary, right? He'll convert this binary into signals. Okay, because network interface card will convert this binary data into signals, right? All these zeros and ones right now, all these binary, this packet is full of zeros and ones, right? That is now converted. Now our packet is getting the transition from binary to what? It's gonna get the transition binary to signals. The same data only. But earlier it was, when it was in the PC, it is in binary format. When it is gonna go through the cable, right? Because we have a cable connection over here. You can see, this port, you're going to connect a cable. It is a LAN port, LAN cable. Yesterday, I showed how the LAN cable will look like. So we are connecting a LAN cable over here. So in the LAN cable, this zeros and ones are now transferred, or it is transmitted as what? Signals, right? This is what a signal is. Now the signal format, the NIC will convert. So binary to signal is what the NIC's work is. Right? The binary data is converted into signals. Right? That's what the NIC does. And that is what the work of the physical layer is. In physical layer, what exactly happens is the network interface card converts this binary packet into signals packet. The packet is same, but just the way of thing is different. The way instead of binary format, it is now in the signal format. Right now, this guy converts it to signals. Okay, clear for the point? Okay, so now once the signal leaves, the whole packet now got converted from binary to signal, and now it's traveling into the cable. Okay, clear? Right. Okay, now let's take the same OSI model only. I'm not going to go to the next topic. Let's take a different slide just to understand how the conversation is sent from one PC and it is received in the other PC. Okay, so let's go and take this slide. I'm just looking for the right slide, please. Okay, yeah, this guy. So here you have two PCs and how they're going to communicate with OSI model concept. Okay, here you have OSI model. Here you have NIC, and now it's going to transmit it to this guy, and this guy has got the same OSI model. How you're going to receive the packet? That is what we are trying to understand. Okay, so let's assume that I take an application. It can be any application, right? It can be WhatsApp or browser or whatever it is. Okay. Now we all understood that the first delay is what they do. They generate payload. That's what we understood, right? Are they going to generate the payload by themselves? Or are these guys going to generate the payload by themselves? No. Who generally generates the payload? Who gives the payload? Who is the source for the payload? We, the user, right? The user who's accessing this PC, the user takes this PC, right? And he opens some application. It can be WhatsApp application also. Let's simply take this WhatsApp application. This guy is opening WhatsApp page. Now the user is interacting with whom? The user can interact only with the application, right? That is why we have application layer at top, which can interact with the user. The user is opening the application in his PC, right? Like WhatsApp, and he's typing hi message. Okay. Now the hi is the message that he typed. Now what happens is, now after typing hi, he sent it. He just pressed that enter button. Now what happens? Now this hi message, which was no, the application took the input from the user, and now he transferred it to, or he sent it to the presentation layer. Now, what presentation layer will do is presentation layer, when the presentation layer takes the high, what is the responsibility of presentation layer? I told you we're not going to really worry about the first three layers, but still I'll tell you, right? So that you can have a little bit of understanding about what a presentation layer does it. So the presentation layer will basically encrypt the data, because in WhatsApp it's completely encrypted. We know encrypted conversation it is. So the encryption happens on the presentation layer only. The application layer gets the input. When the application gets the input, the data is clear text, it's high. Now what happens, the presentation, when after getting the input, he gives to the presentation layer encrypts it. Okay. And then next what he does, he forwards it to the session layer. What session layer will basically do is, again, this is a little bit of complicated layer, because a session layer, as I told you, that's programming people, right? People who develop applications, they know about the sessions and all, right? There'll be some kind of a session key. Okay, that key will be used to track the conversations or track the sessions. Maybe simply I can give you an example. Whenever you log into banking websites, okay, and you log into the banking website and you stay idle for some time, right? What happens? Automatically the bank website logs you out, right? And have you seen one message? The session expired. It means, what is the meaning of it? When you try to log in, the PC got a session key which he was using, and that session key got expired. Right? I'm not gonna get technical into this and all this. So let's understand simply, like, the session layer is adding a session key along with a message. Right now, the message is there, it is encrypted by the presentation layer, the session key is added. The session key is added by the session layer. Now, in the whole, we call this as what? We call this as payload. What idea? In the whole, we're going to call it as a payload, right? The encrypted message, session key, and everything together only we're going to call it as a payload. The payload is ready, right? This black color box is what the payload is. Okay. Now what happens? The session layer forwards to the transport layer, right? This is layer 4. Layer 4, layer 3, layer 2, layer 1. Okay. Yeah. So now this guy, right now, this is what the payload is. The payload is now ready. We say no, payload is ready. Now the payload is forwarded to the transport layer. What happens in the transport layer? Transport layer will add a new cover. Okay, and it will have new cover, and what's gonna have? It's gonna have layer 4 headers. It's a layer 4 cover, and it's gonna have what? It's gonna have layer 4 headers, right? I'll just put it over here. Layer 4 headers are available in this cover. Okay, example: source port, destination mode, sequence number, acknowledge numbers. These are the different layer 4 headers we have. Okay. Now what happens? This guy will send it to this guy. Right now, network layer. So we cross this, we cross this, we cross this, we cross this also. Now network layer, we're just trying to cross network layer. What network layer does? Network layer puts a new cover. This is layer 3 cover. Okay. So in layer 3 cover, what happens? Source IP, destination IP, everything is getting added, right? Along with some other headers also. Okay. I'll simply put it as layer 3 headers. We'll generically call it as layer 3 headers. Headers are added. Now what happens? Now this is again transferred to data link layer. Okay, so transferred. The packet is becoming bigger and bigger and bigger, and finally in data link layer, the packet reaches its maximum covers, which is the layer 2 cover right now. Let me add layer 2 cover over here. Layer 2 cover, okay, and layer 2 headers. Okay, so now again physical send. Now the whole big packet, big parcel. Now it is in the physical layer. What physical layer will do? What you have in the physical layer? There is a small network interface card, which is an RPC. What this guy will do? This packet, which is in the binary format, which is in zeros and ones format, this guy will convert that into signal. And finally, it goes to the receiver PC. Receiver, what he'll do? Receiver also having a network interface card. No, this NIC will receive it. And what happens in the receiver side, guys? I think most of you guessed it, right? What happened on the sender side? The covers were added. On the receiver side, the covers are removed. Okay, so this network interface card, what it does, what is the duty of the network interface card? Right now, what it is? It is in signals, no? Because cables, in cables, you can transfer only signals. Now, after reaching this network interface card, these signals are converted back to what? Converted back to bits. Okay, now the packet, the whole packet, which was in the signal format, now got converted into what? Now the packet is in the bits format. Right now it is in zeros and ones. Right now it is in zeros and ones. What data link layer will do? So this guy converted, right? This guy converted this NIC, getting a signal and converted that into binary. Right now, this is what our packet, which is in the binary format. Now he gives it to whom? He gives it to data link layer. What data link layer will do? Can anyone guess it? Yes, I think what you guessed is correct. Okay, so what data link layer will do is in the sender's data link layer, what was added? The layer to cover was added. No, what the data link layer of the receiver will do? Will remove the layer to cover, right? So it has been what added on the in the sender side's data link layer or layer two. This side it is removed. So now the packet, the first cover of the packet is removed. Now given to what? Now given to the network layer. Now what network layer do? What network layer will do? Right? He is a layer 3, you know what he does? He'll see layer 3, right? Again, he this guy, right? This data link layer was seeing the layer to cover and then he was removing it. Right? After removing it, he is passing it to whom? He is passing it to the network layer. Now, what network layer will do? He'll see the layer 3 cover, he'll check the layer 3 cover, and after he'll remove that cover. And what he does? He removes this guy removes it. And now he sends it to the transport layer. Right now, what transport layer will do? Transport layer will again remove the layer 4 cover. Right, this is layer 4 cover is removed by the receiver's transport layer, and now he gives back to the session layer. What session layer will do? Will remove the session key. The session key is now removed. Okay. Okay. What happened on the sender side, guys? The reverse is happening on the receiver side. Now what he'll do? He'll give it to the presentation. What presentation layer will do? He'll right? He'll just decrypt it, right? He'll decrypt it, right? Once he decrypts, what is that? What is that? You have a hi message. Now the hi message is given to the application. Now what the application do? The application is to show this hi to this user. For the point, the user is just looking into his monitor. In that monitor, what he got? He got hi message, which was sent by whom? Which was sent by this user. This user sent hi message. All the way we crossed all the OSI model concepts and all, and now it has been transferred through the wire. Again, coming back, reverse, 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 reverse. Everything is reverse happening, and this hi message went to the PC. Okay, this is what happens, guys. Let it be a simple hi message, or it can be big data, big file, whatever it is. The same process is what happening when it comes to data transfer through between the computers, right? And this is why I say OSI model is very important. OSI model gives you the idea of what, how the data transfer happens. Right? Generally, data transfer happens with how many layers? You have a payload, and then you have a layer 4 cover, and then layer 3 cover, and layer 2 cover. Right? So it's a concept of covering. That is why we called it a layers. Okay, so fine. So next thing is maybe initially, if this is the first time that you guys are seeing the OSI model, then I know that it is very tough for you guys to remember the order. For that, I'll just give few statements which I came across from internet. Right? So you should never change this order, guys. If you change the order, then completely it's wrong. Right? So what if you put this transport layer over here and put the network over here? Right? Which means in that case you're saying this layer 4 is here and then layer 3 is here. That is not how networking is happening. How networks works? Network works like this: layer 4 and then on the layer 3. The receiver will first see the layer 2 cover, and then he'll be expecting layer 3 cover, and then he'll be expecting layer 4 cover. But if you change the OSI model order, let's say transport and network, you're just changing the order, then you say that layer 4 is there and then you have layer 3. That is not how the packets are crafted. That is not how the packets are sent, right? So OSI model order is very important, right? And how can I remember the order of the OSI model? We can start with application, right? Yeah, so that's the first order. So let me, that's the first layer. And wait, so A, B, sorry, A, B, S, T, N, D. Okay, so you can just see I circled only the first characters of those layers. Now I'll simply say this case. I'll write it also. Please do not throw sausage. I'm not sure of the spelling. Let me write something. Sausage. Let me just get a spelling from the Google, please. Sorry. Just a statement. It has got sausage. I'm just typing something. Google will suggest me. Yeah, this is the sausage. Okay. Okay. I don't know even what is that. It's just a meat, I think. Okay. So this is a statement I know. I just came across sausage, sausage, pizza, 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 away. Yeah. So can you guys repeat this with me? Please do not throw sausage pizza away. Right. From this, what I'm trying to say is this is this is some advice I'm giving to you guys. Right. Just take this advice, and with this advice, what you have to understand is you have to say P. P. Okay. D, D, N, N, T, T, S, S, P, P, A, A. Okay. So when you take this advice from me, please do not throw sausage pizza away. It says that you are just writing the OSI model in the right order. Okay, from top to bottom. Sorry, from bottom to top. Okay, got the point? So yes. So yeah, this is what I wanted to discuss in today's class. I thought it'll take maybe close to 2 hours, but I don't know, I completed fastly. Yeah, that's okay. Anyway, this is what the plan is, guys. I just decided to discuss OSI model only today, right? I don't want to get into the other topics and all because OSI model itself is a big topic. It takes some time. Maybe you can just go and refer some YouTube videos also. But a chance are there that people might confuse you because after YouTube, everyone's become a trainer. So see OSI model or refer OSI model from a quality trainer so that you'll be able to understand what exactly it is. You don't confuse with what OSI model is. Okay. So yes, I think we have time. So let me just get a feedback from this session, guys. Yeah, so I'll just give a poll. Just try to answer how much you wanted to rate. Okay, I'll just give. Wait, I'll just create one more poll just to know the level of and how you guys like this classes or not. Just this session. Okay, see, honestly, give me whatever honest feedback you guys have. I don't have any issue with in getting a average feedback. Guys, just share whatever feedback you think. Uh, so it's excellent, good, and then maybe average, and then bad. So I'm not going to share this result. This result is going to be for me only. I'm not going to share this result just to know the rating of the session. I'm just asking this question. Okay, so please wait. Okay, I think yeah. Okay, please answer the poll, please. Okay, so yes, really, nice to know the results here. Okay, so the result is for me only. It's not for you guys. I'm just gonna end the poll, not gonna share the result. Yeah, so yes, I can see, I'll just say I'll say good and excellent altogether it has got 97%. Okay, good and excellent has got 97%, average has got 3%, and you guys are really nice. No one gave me bad. Okay. Yes. Okay, so fine, thank you. Okay, guys. So yes, I'm just gonna end the meeting now. We are supposed to have it till 8:30, but it's okay. Since it's a theory class, let's have it like this here. Let's stop it here. Understand what is OSI model. Just recall the concepts and all. Tomorrow we'll meet with a different topic, and also you guys know, no, it's going to be a continuous session. We don't have any um, weekend break and all. So we're just gonna have it continuously from August 3, which is yesterday's class we started. We're gonna have it till August 17 without any break. Right? Just try to travel with me for this 15 days. I know 15 days sitting in the evening is tough, but please manage. Right? It's a free session, right? So I want you guys to make use of it. So 15 days, try to stay with me. So tomorrow we'll again meet at 6:30. Maybe tomorrow I think I can take till 8:30. I think so. Okay, I'm not going to take the questions in the chat, guys, because you just you just have your question, and you can mail to this mail ID, me@poundrush.in. Okay, or maybe even recording students who watches this recording also, you can just mail to this. Either me or my assistant will be answering these questions. Okay, so that's my mail ID. You can forward it to this mail ID, right? So don't ask your question in the WhatsApp page because already have many hundred message in WhatsApp, right? Almost 100 plus 100 messages I have. I cannot go through your chats also. So please, whatever questions that you have, please mail it to this mail ID. Myself or my assistant will answer you this question, answer your questions. Okay. Yeah. So nice having this session with you guys. I really enjoy the session. So upcoming sessions also, it will be even more interesting. This is a theory class, but upcoming classes we'll do labs also, right? Yes. So we'll end the session here, guys. See you guys tomorrow at 6:30. Okay, so every day we're gonna have a different Zoom link only, and share the Zoom link in the WhatsApp group before the class starts. Okay, yeah. So thank you. Thanks for joining the session, guys. See you guys. Bye. Thank you.